Hello. What I want to show you right in this video is a factory game that I made. It's a prototype I've been working on for the past week. You can build drills, conveyors, refineries, and you can send them to some input. In this case, it's a dock. You can control the time flow, look at the stars, but the main goal of the game is to meet the deadline. And we are about 1 kilogram short. So let's fix that. Let's build more drills, more smelters, more conveyors, and as you can see, they're starting to overheat a bit. That's not good. So we have to build radiators so that we can redirect the heat before they blow up. Radiators also have the chance to blow up too, but I think this is fine for now. And now, as you can see here, we already hit our target. And now we can sit back and watch our factory operate. Alright, we have 370 grams of surplus, and we get 50% of it to be added into our inventory. This is needed because of the next phase, in which we'll sell it onto the stock market. Now we only have 180 grams of iron. I guess I'll fine-tune the values later, but for now what matters more is selling at the right time. In this case, I think this is good enough. Let's sell before it dips any lower. Or I think it did dip. Good thing I sold early. Now, once we have nothing left to sell, we can either wait for the markets to close or you can skip in advance. And now in this phase, the marketplace phase, we can buy bundles or from generics in what structures we want. Bundles allow us to have a discounted price and a lot of structures, and also contain some unique structures that are not present in generics. In this case, it's the dock. For now in the generics, I'll buy a drill, a radiator, and some smelters. I think I have enough conveyors. And finally, for the contract selection phase, we'll have a look at our asteroids, the base pay, and what targets we have to meet there. In this case, I think I'll select this. It's big enough and has a rather generous target. And that's pretty much the main game loop of my prototype. Now, that's one part of the video. The other part of the video will consist of me basically explaining how I managed to make all of this, as it's kind of an interesting learning process, and at the same time it's very tedious, and there were a lot of hiccups I went along the way. So let's start. The video is split into 3 parts: the minor stuff, the big one, as well as a few updates guys I'll give up for the nth time because I'm a loser. I'll start with data organization, then the stock market RNG, and finally the asteroid select. The main data is divided into two: structures and resources. The actual instances that contain their behavior are these two guys. They each have their own autoload handlers and are completely separate from the display part of the game. The stock market basically uses the randef function from Godot's RNG class and gives me values based on a random distribution. The resource data already has this and basically prevents a bit of bullshit like this. Making this essentially forced me to refactor how I generate my maps and essentially put it somewhere else. After I get the data, I do the old classic make an image and draw on trick, and then I load as a texture, of course. A lot of rewiring was simplified, but that was the gist of it. And now it's time for the big one. Now for some basics, the game loop heavily depends on two things: the state and the tick. State is for the stats and tick is the time. For every tick, the game processes the state before the tick and leaves you with a new state after a tick. If a box is this conveyor, then on the next phase it should be on the next conveyor. Pretty straightforward and sounds easy enough. First off, let's do the simple straightforward approach. If the structure is free, output, otherwise don't output. Very simple, doable in 1 hour, and look, it goes around a cute little circle. It works, perfect, so let's now put in more than one resource and oh fuck. Let's try to see what's going on here. Basically, there's one big problem with the naive approach I have right now. You see, the conveyors behind read the conveyor ahead and thinks, oh, it's full, I'm smart. What these structures lack, however, is foresight. It doesn't know that on the next tick, the conveyor will be free, but it should have pushed through because that's how conveyors work for God's sake. Now, it is just possible to keep on looping through every structure until it stops changing, and it's actually a valid solution. This is rather similar to another solution to the max flow problem problem which has basically a big old complexity of near infinity. But there is indeed a better way that I ended up adapting in my current implementation. Suppose this congested conveyor network, if you try to draw a line from one end to another, you can see it's one possible way of solving a conveyor flow. Now let's do that again and again until we have every single possible way of resolving it. This now leads me to my current implementation, tree traversal. I start from the root and simply run along one of these lines and tell them all to push. And if the root can push, then I simply don't give a fuck. So for every tick, I first process all the connections, forming trees along the way, and finally getting every single root and updating every single structure on it. With some optimization, I now have a linear time conveyor chain resolving tick loop, and it's all contained in these functions so I don't have to jump around my 50 script project. Now, of course, there's some edge cases like cycles, and for that I decided to just simply not care. And that kind of makes sense, they're not going anywhere anyway. Finally, you may have noticed the asterisk at the beginning there. Let me explain. This is all because of a new building I wanted to add, an overflow conveyor. If the direction ahead is full, then we push. Otherwise, we push elsewhere. Now let's revisit my current implementation and why this has prompted me to refactor my work. My implementation currently assumes that once the output is finalized, it will never change. However, the overflow conveyor could change its final output, which breaks down the entire model. It's worth noting I already came up with a solution for this, but I haven't implemented it yet, so I'll talk about it another time. Alright, that's about it. Thank you for listening. To close things off, I also have a few things to say. I'm not gonna lie to you, this is obviously kind of a strange mix of genres I'm doing, and I'm not even sure it will turn out well, but right now I am currently having fun making it and sometimes playing it. So if you're interested and you have some idea on what I should add next, feel free to comment it down below. And like every programmer out there, I finish only like 1 out of 100 side projects. But with every attempt at this, I do feel my motivation somewhat lasting longer. So hopefully I was able to finish it at least to a playable degree or demo. Finally, chances are the first commercial release I'll actually get is that snake game in my channel that I haven't talked about yet. Even so, my motivation is now high again, and I think I'll try to work on both prototypes and hopefully get out a polished version of that snake game. And that's the last of it. Thank you for watching, and hopefully you're still here to listen to my ramblings. See ya.